Question 3C2 says, determine the coordinates of the point on F where the tangent to F is parallel to the line AB. So if the tangent is parallel to the line AB, then it would be a line that is something of this sort. So we are looking for the coordinates of that point where that line would be a tangent. And in order to do so, we first need to get the gradient of this line. So the gradient of line AB will be equal to, you can do the whole change in y over change in x, or you can recognize that this is going from -3 to 3, which means the gradient is 1. But it's safest to just compute it. So we'd have 0. Actually, I wrote these coordinates incorrectly. This should be 0 as to -3, like that. So this will be 0 minus -3 all over 3 minus 0, which will give us 3 over 3, which is 1. And once we have this gradient, we also know that this gradient will be equal to 1. And we know that the first derivative of x describes gradient as well. So we can find the x value on this parabola where the gradient is equal to 1. And in order to do so, we need the first derivative. So that will be equal to 2x minus 2. And we're looking for when the value of the gradient is 1. So taking 2 to the other side, we get 3 is equals to 2x. Divide both sides by 2. We get that this occurs when x is 3 over 2. So we now know that this is about 1.5. And as well, we can find the y value by substituting it into the original equation of the parabola. Since we now have the x value there, we can get the y value, and that would be x squared, but in this case x is 3 over 2, so 3 over 2 squared minus 2x, which is 3 over 2, and minus 3 to give us an answer of minus 15 over 4 as our answer. Therefore the coordinates will be 3 over 2 as minus 15 over 4.